I want to talk about something we'll refer to as measures of central tendency. And I am now into chapter 3 of the Whit book. We're just rolling along here. Measures of central tendency. There are 3 of them, and you already know about all of them. You may not call them what we'll call them, but you already know about them. And they are mean, median, and mode. I'll start with M. The mean is what we typically refer to when we say the average. And the average, as I alluded to a little bit earlier, that's when you add up what all you've got and divide by how many you have, and that's your average. Be it your test score average or whatever average of any set of numbers, instead of interval or higher numbers, I should say. So, now the problem we run into in teaching something like statistics is that sometimes, I guess it's to make ourselves look smart, we try to say simple things in confusing ways. That's why we say things like, I'm not going to talk about the average, I'm going to talk about the mean. Well, okay. And as I said a minute ago, just kind of plain language how you get that. Here's the way we say it in statistics. First of all, we've got a symbol for mean. I have to draw now, so pardon me on my handwriting. If I can. X bar. You know, we typically, so we were talking about variables a minute ago, mathematical variables. We think of the term X, which is why I used the example X a minute ago. The average of all the X's, X bar, that's the mean. Now, how do we say we got that average a minute ago? You add up what all you have. Here's the way we say that. We don't just say add them all up. Well, we do, but here's how we say it. Sigma X, or sum of X, Greek letter uppercase sigma. Sigma X means add up all those that you have. And once you get that total, what'd you tell me we do with it? We divide by how many we have. The number of them. So we're not very creative here. So there's your first statistical formula, which you already knew. But if you saw that, you probably wouldn't know what they're talking about. But that's what it means. Average is X bar. Add up how many you have, divide by how many you've got. Now let me make one more slight distinction here. A lot of times when we're making the distinction between population and sample, we'll let that be denoted by upper or lower case. For example, N is number in population. Uppercase N. Small case N is number in the sample. That'll matter a little bit a little later. But let's just say we've got everybody we're talking about. Add all the values together, divide by how many you have. So that's the mean. Now, the median, let's say I've got the numbers, the numbers 2, 3, 5, 5, and 7, and those are in order. So the median, it's just like, median sounds like middle, that's exactly what it is. It's the middle number. In this case, it's the 5, the first 5. So the median is 5. It's the number in the middle. The mode is the one that shows up most often. So the median is 5, and the mode is 5. So what if, let's say I had another number. What if I had a 1 here. Now what's the median? It's between 3 and 4. So halfway, I'm sorry, between 3 and 5. Halfway between 3 and 5 would give us a new median of 4. The mode is still 5. Now, there's some differences in terms of which of these is appropriate. Now, remember back to our discussion about nominal data a minute ago? And I said we could go count the cars of particular colors in the parking lot, and we could find the most common color. That's kind of like the mode. So there's sort of a nominal mode, just like there's the numerical mode here. But you can't find the median. You can't find the mean. But you can find the mode, those kind of things. Sometimes, if we graph these out, and here's some examples to where one thing might be better than another. If I graph a normal curve, and by the way, do you remember high school geometry? Okay, do you remember there is such a thing as high school geometry? Okay. And we plotted curves. We plotted lines or turned equations into lines. And we had a graph that looked like this. And it divided the paper or the board into 4 places, 4 areas. And those areas are called what? They're called quadrants. Quad means 4. There's 4 of them. And we labeled quadrants. I don't know why we label them that way. It makes no sense at all. But anyway. Think of our graphs, our curves that we're doing, think of that as quadrant 1. Kind of the upper right of it. So, if I've got a normal curve, or any kind of curve at all, and that represents, say, test scores from 0 to 100, which wouldn't be normal, but pretend it did for a second. That's like everything's positive, how many students, how many scores you had, what the scores were. That's kind of like the positive. Both variables are positive up in the first quadrant. Now, we said that a lot of things graph normally. Let's identify, that's not a great normal curve, I can do a better one. Not bad. Let's find the 3 measures of central tendency in a normal curve. Well, let's go with the easiest one. Let's go with the mode first. The mode is right here because that's under the highest point. That means there are the most of them. So there's the mode. Now, let's look at the median. The median is the middle. Where's the middle? Same place. Likewise, so is the mean. So in a normal curve, all measures of central tendency, the mean, median, and mode, are all the same place. They're all right there in the middle. You got the left half, you got the right half. There's symmetry here, and we'll talk about how far away you get from those measures of central tendency in certain terms later. But for right now, that's what you've got. The most common thing to report with a group of data, and we call a group of data a bunch of numbers, a distribution. Usually you report the mean. And that's the most common and probably more often the best one. But sometimes you get something like this. And I'll continue with my same example of the classroom scores. And we said that was skewed. Most of our scores are on the higher range. Let's identify the measure of central tendency again. Well, the mode's going to be under the highest point. Where do you think the average is going to go? It's going to go to the left, somewhere over here. And the median's the middle, so the median's going to be between those somehow. Let's think of it this way. Let's say I've got one person's set of scores. At this point, what's the average? Doesn't take a lot of advanced calculations to do this. The mean is 90. How about if I throw a 0 in there? What's the mean at this point? 72 is what I was thinking, yeah. So look how that extreme lows where that outlier, look what that did to the mean. It pulled it artificially down. So in a skewed distribution, outliers pull the means in those directions. Is 72 a really probably the best indicator of this person's performance? Probably not. Probably if I can get this right, probably didn't know nothing for that 0 he got. I think I said that right. So the mean is pulled in the direction of the extreme. Now, I said this was skew a minute ago. Do you think, not a trick question, but a loaded question, we describe skewness as either positive or negative. Do you think this is positively skewed or negatively skewed? Of course, now that I said it that way, you're on your guard. This is negatively skewed. It's negatively skewed because the mean is pulled in the direction of the skewness. That's why it makes sense to call it negative. It looks positive. Well, it looks like most of them are on the positive side. Well, but that's not the way we look at it. We describe it in terms of the direction that the mean is pulled, and the mean is pulled artificially lower. So it's negatively skewed. So your classroom test scores are probably going to be negatively skewed. Remember that student that made the 15 a little bit ago? He's pulling your class average down artificially. What if this last score had been 100? How much would that have pulled it up? And the answer is not much. Because 100 is not an extreme score. 100 is not an outlier. 100 is not too far out of the neighborhood of 90, but 0 sure is. So extreme scores will artificially pull. I don't say artificially, mathematically it works that way. But I say this because if you're a classroom teacher, I'll just give them a 0. Well, know what that 0 does. Now, I'm not saying don't do it. I'm just saying that may do something you really don't intend for that to do. So be careful of that. So advantages and disadvantages of that kind of example. Another kind of example, I'm going to wrap it up here before too long. When you watch the economic news, and they give the real estate reports, they talk about housing prices, and they're pretty good about this. They typically do not report the mean house price. They report the median house price. Here's why. I could ask how much a house costs or how much your house costs, and we'd all say within a fairly broad range, but certainly not all inclusive of the housing prices. Most of us live in a house that costs within a fairly small range. But sometimes you get extreme scores. Anybody live in a $5 million house? Or let me rephrase it. Does anybody here live in a $5 million house? I doubt it, but some people do. How many people do? Not very many. So if I graph housing prices, they're going to kind of look like that. They're going to be skewed in the other direction. So I can do it better than that. Here's my median, here's my mode, because that's under the highest point. My mean is going to be to the right this time because those relatively few extremely high-priced homes are going to pull the mean up there. Think of mean as sort of the balance point. Those people out on the far end, they weigh more than the people close to that. So, and my median is going to be somewhere in the middle here, probably. So, most of us live. We can probably afford the median house price based on an educator's salary. I don't want to be the bearer of bad news, but none of us, as long as we stay in education, live off that, none of us are ever going to be able to afford the average or mean house price because it's pulled artificially high by celebrities, athletes, entertainers, things like that who live in the $5, $12 million homes. Because that raises that mean artificially. The other thing, I could draw the same picture with salary and talk about the same people. Most of us are never going to make the average salary, but we might make the median salary. A few years ago, the University of North Carolina did a study, and it looked at the average salary by majors that the students had graduated. Do you know what the highest average salary was of major? Again, you're set up here. Okay, app design, yeah. Okay, technology, electronics, yeah. Pretty high, probably above the median, but that's not it. Business, medicine, people name all those things. None of those are it. You ready for it? The highest average salary by major of University of North Carolina graduates at the time, is just probably 15, 20 years ago. Sociology. Think about that a second. No. Nope. Sociology had the highest average salary. There's a very simple reason for it. Michael Jordan was a sociology major. I would argue the average salary by that rate is not a fair picture. So you have to be careful with statistics. So there are advantages, there are disadvantages in terms of measure of central tendency. Most frequently, we want to report the mean. Sometimes we want to report something else, though, like average housing prices and salaries, that sort of thing. Because the mean doesn't really give you a realistic picture. Sometimes you want the median instead. Questions, thoughts, comments? Okay.